It is now my privilege to introduce our distinguished speaker for this evening's memorial lecture, Dr. Sanjeeva Kumar Jha, former head of the Department of Statistics, Northeastern Hill University, Shillong. A scholar of great repute, Dr. Jha has contributed immensely to the field of statistical science through his academic leadership, research, and mentorship. Dr. Jha, our esteemed keynote speaker this evening, is a proud alumnus of Patna University. He completed his graduation in statistics from Patna University in 1981, followed by a master's degree in the same discipline from the same institution. In 1986, he qualified the UGC NET in statistics, marking a significant milestone in his academic journey. Dr. Jha began his teaching career in 1994 as a faculty member at the PU College, Mizoram campus of the Northeastern Hill University. He was awarded a PhD in statistics from Patna University in 2003, specializing in distribution theory under the guidance of Prof. Amarendra Mishra. In 2005, he joined the Department of Statistics at Shillong, where he has continued to serve with distinction. He has also held the position of head of the department, contributing significantly to its academic and research development. Dr. Jha brings with him over 30 years of postgraduate teaching experience in the field of statistics. His primary areas of academic interest include probability distributions, statistical modeling, and spatial statistics. A dedicated researcher, Dr. Jha has successfully undertaken and completed nearly half a dozen research projects and has published extensively in reputed national and international journals of statistics. He has actively contributed to the academic community by presenting research papers at the numerous national and international seminars and has been invited to deliver expert talks at various conferences and academic forums. His commitment to research and mentorship is evident in his successful supervision of 2 PhD scholars and several MPhil students. Renowned for his clarity, depth, and engaging teaching style, Dr. Jha is widely regarded as a brilliant teacher of statistics and enjoys immense popularity among his students. Today, it is now time for the highlight of this evening, that is the Devendra Mishra Memorial Lecture. The topic for this year is Statistical Science Over the Years, the Way I Understand It. We are deeply honored to have Dr. Sanjeeva Kumar Jha share his insights and reflections on the evolution of statistical science through the lens of his rich academic journey. Over to you, sir.
Thank you, Dr. Priyadashini, for such a nice introduction. Respected Professor Amarendra Mishra Ji, Director, Devendra Mishra Institute of Statistics, Patna, and to my mentor, my PhD guide, and my teacher during my Patna University days. Respected Ajit Kumar Sinha Ji, the Managing Director of Devendra Mishra Institute of Statistics, Patna. My teachers that I can see here, Professor Arun Kumar Sinha Ji, Professor Shrikant sir, and all others, the senior alumnus of Patna University, students, and my friends. It's a great honor, I feel, when I was offered this chance to deliver the Devendra Mishra Memorial Lecture 2025 on this auspicious day. I'm honored, and I thank the management committee. I'm grateful to the management committee for being given this chance. Sir, my journey in Patna University started in 1977 when I joined Science College, Patna. In 1979, I joined Department of Statistics, Patna University, under the combination PMS, Physics, Maths, and Statistics, because those days the admissions were offered in a combination. I was interested in getting physics honors, but I was told by the head of the department of physics to meet once the head of the department of statistics, to which I did. Professor Anand Mishra, Anand Prasad was then that day available as head. I talked to him, And somehow after talking, I got impressed and I opted for statistics honors. This is how I entered into statistics. I have a brief interaction with Professor Devendra Mishra, late Professor Devendra Mishra, in my classroom when he was teaching us testing of hypothesis, but that was brief because once in 1979, another socio-political event was taking place because that was the year when Mandal Commission recommendations were implemented and the many parts of India, including Bihar, surged with political violence. Patna University was also greatly affected. And during my graduation and my post-graduation, we had more of sine die span than regular teaching days. So we have very less interaction those days with our teachers, and what we studied, that we studied among our peer group mostly. And apart from statistics, we discussed there many other things. So in some way, it was fortunate, in some way unfortunate, because regular classes of statistics we missed a lot. The disturbance was so much that our master's examination continued for nearly an year. And during the master's examination, I enjoyed more two trips. One rock climbing course for 10 days and a cycle trip to Kathmandu from Patna. Classes are unfortunate because our peer group, we were able to discuss many of the other topics also, like philosophy, like metaphysics, like our subjects, even physics, statistics was also there. Then with literature, Hindi, Bangla, Urdu, we discussed those days and we were enriched in some way. Well, have to organize because I got a little disturbed on my speech. So what I was saying, yeah. Well, apart from games, sports, athletics, gymnastics, rock climbing, and trekking, we have the interest of mathematics and statistics also. It is magazines and books also. One of the magazines that I could access was December 1977 issue of Science Today. It was Science magazine, and that magazine, one article, many faces of statistics by legendary late national professor C.R. Rao was published, and that became my main argument tool during peer group discussions. That article has many interesting examples on statistics, and later on I could find some more examples in the book by C.R. Rao, Statistics and Truth. I request all of those who are interested or linked in some way to statistics, that please go through the book, access the book, Statistics and Truth by C.R. Rao. You'll find many interesting applications of statistics that you can find there. After my master's, actually I got UGC GRF NET that time in 1986 and joined as a PhD scholar in the same department. But 2-3 stories and applications is coming to my mind. Slowly I'll take it up. Well, please bear with me because the order I missed out somehow. The first two examples that I'll be quoting, that one while studying, one example I could read that there was a time when Mughal Salai station, which is now called as Deen Dayal Upadhyay Junction, that used to be very crowded and most of the passenger trains used to get very delayed there. It was a very important station between Delhi and Kolkata. So once a few teachers from ISI were crossing and they have to wait there for a very long time to miss the meeting for which they were going. So they took up the challenge and they tried to propose some model, network model. And after that, this was implemented. And even today, we have smooth functioning of passenger trains in Mughal Salai Junction. So this example, I read, I could get some more information that, and I was interested in proposing a PhD because my schooling was in DVC in different projects like Maitan, Chandrapura, Panchet, Bokaro, Tilaya, and nearby all those CCL, the Central Coalfields Limited was there. And we were facing several times. That time it was started, the blockage of roads due to trucks, overloaded trucks that they used to transport coals from washeries to mines and again to other selling points. So I started my PhD topic just to find out some solution for efficient movement of trucks there. So I entered into the task because my childhood was there. Many of my friends were there, and some of the friends who joined there, working there also. So I could access data from mines. I could access data from say washeries, a number of trucks, and all those. But finally, I had to get some cost data from their headquarters, which was stationed in Ranchi at Darbhanga House, they call it. But there I was denied entry, and by no means I was able to access that. But somehow, because one of the friends was there inside working, so I just requested him to check my figures from the figures available. So he said, no, there's a very vast discrepancy between the figures that I have collected from mines and washeries. That doesn't match from the figures that is available there in Darbhanga House. Now I talked to my supervisor, and because the cost figures were not available at all, so then we reached at a conclusion that no, this cannot be carried forward, and I have to drop the topic. In between, I'll again go back to my classes of graduation and MSc. Well, initially, I must accept today that I was completely lost in this subject, statistics, because the due respect to my teachers, but because what was happening that suppose one classroom teaches us probability theory. Now that probability theory, after say 1/3 of a year, they take to define the probability theory because it goes via set theory and measure theory. Then we have to learn all about this fields, sigma fields, and Gödel fields, and then we come to a definition of probability. But suddenly it was told that this definition of probability is not going to help you in calculating the probability of events. For probability of events, you have to use something else. Now, in our books that we used to follow, we have 3 more written in the name of definition of probability. Like one is classical definition, another is relative frequency definition, the third one is subjective probability definition, and there are more. Classical definition, I was told that classical definition, though it is written definition there, but it's not a definition. It only helps you in calculating probability of events only in a very specialized condition, in equivalent likely type of situation. Other situations not valid. Now, it's not a definition, but it goes in the name of definition. It allows for calculation, but calculation in the very limited conditions. Similarly, the relative frequency definition also has its own limitations, and it is not a proper definition. Like was a subjective one. Now, there were some discussions with Professor Sikant in those days, I remember, and we could accept that only the probability we can work with that is in that equally likely setup. Otherwise, we are not converging to a point. Now, the thing is, when I started studying statistics, I thought that probability theory or probability is the building, this foundation of statistics. So I must learn that. But when I entered to some other classroom, say, which is giving you descriptive statistics, they hardly talk of probability. They were talking of something else, all those mathematical or say algebraical things. I entered into another class that is dealing with probability distribution. Now there I came to know that the probability that I'm doing in probability theory class is not the probability what I'm going to discuss here. It's a different kind of probability. It's an induced probability. And it has its own limitations and its own applications. I'm really confused. And the worst was that once later on when I was introduced to sample survey and design of experiment, I was told that these are the methods where you can collect data. Now the problem is that this collection of data was taught in applied statistics. Once you do the basic, then you come to applied. I was simply not able to get any connection between all these different courses of statistics. And I should say that I was disappointed to some extent and was completely confused at what I'm doing. Much later, when I started teaching, then I could understand that this probability theory or probability is not this building block of statistics, but is a pervading idea of statistics, which it enters into all the branches, and somehow it links all the different courses on all the different topics that is being discussed in the name of statistics together. After, again, I'm coming back to my discussion with the students. Just a minute. So my PhD days, I was talking. So PhD days, when I have to drop my PhD, and I was upset a little bit. And one more thing that I would like to recall that if I remember correctly, Professor Shrikant Singh joined the department in 1979. And there was 3 vacancies in our department in 1981. And I got GRF net. This net that time was net UGC in statistics, and this you expand the acronym net. That time we read National Educational Test. Nowadays it reads National Eligibility Test. And the idea of UGC that time was that those who will clear this net, they are only supposed to join in PhD. And then if after successful completion of PhD, they are eligible to join as a lecturer those days. But I waited for the post because I was sure that whenever the interview takes place, I'll be absorbed in Patna University. But I'm sorry to say that those 3 vacancies remained vacant. It was filled only after 27 years. It was unthinkable that time. I kept on waiting for quite a long time. Then I had to migrate to Northeastern region. I joined NEHU in Patna University College in Aizawl. When that time, Professor Mishra, Amarendra Mishra ji was outside the country. When he came back, then I had a talk with him, and he said he rather advised me that why not to go for second time registration for PhD, and I registered under him. That was the time when actually I interacted with Professor Devendra Mishra ji at his residence in Rajendra Nagar, because I used to visit his house. I have a lot of interaction and I have a lot of talking. I learned from late Professor Devendra Mishra ji more about life skills than statistics. But we were talking there. I remember we were talking on reasoning and logic and some other, he used to narrate his own stories and he used to encourage me. That was the time really when I properly met Professor Devendra Mishra ji. His personality, the aura of his personality demanded respect, and we respected during college days also too much. Though he was soft-spoken, very less spoken, but we had a good chat there occasionally whenever I visited him. My Shraddhanjali to him today. I'll proceed. I have prepared a few examples. Like one example, I told you about the Deen Dayal Upadhyay junction. One more story comes to my mind. I don't remember exactly where I heard it, maybe in some lecture or some individual talk with somebody. But this story goes about a Barsoi junction, which is near Nagpur in Maharashtra. So they have also coal mines in Chandrapur and coal rakes, this railway rakes, used to cross through Barsoi. And they were reporting of, say, less number of weight when it reaches colliery. So some statisticians were involved there to find out some solution, and they recommended that randomly 3 of the wagons of the rake, every rake that crosses Barsoi should be checked for the weight. Say the first team that they have shown, and it was done. For some days, the weight loss was almost nil, but it started again, and the same complaint remained that the weight in wagons are three random or rates. Suppose three numbers are the third one, 11th and 17th. So they checked it and shown the people there working there that how to select random numbers. But unfortunately, those same three numbers like 3, 11, and 17 was considered as random numbers, and in every ray, only these three wagons were checked, all others wagon remained unchecked. So the theft of coal or loading of less coal continued. Now, you will find that several such examples are there when the ideas that we develop in statistics or branches that has been implemented in a different way wrongly. In Statistics in Truth, the book by C.R. Rao that I'm requesting, there are several examples, very interesting examples there. Like if I list out, I think previous speakers also in previous years, I've heard some of them talking about those applications. Applications like does our morning height and evening height varies? The answer is yes there. The application, one of the applications is that can a person delay his time of death up to the completion of a particular event of interest? Again, the answer is yes. That's what they got from on the basis of the data. Then there was another interesting example about left-handed and right-handed coconut trees. And this example, just to find a solution to the question that whether a tree being left-handed and right-handed is genetic, or it is based upon some environmental issues or environmental factors. The answer was that it is based upon environmental factors, and this whole story of this analysis is very interesting. I'll not be taking more these examples in details, but I want to take one example that about breeding ground of eel, which I followed later on also, and some new information I'll be giving you. So in this second, this span of time, I'll just be talking about three interesting examples. Then I'll be shifting to some other things. Now, just let me present myself. So I'll just go to those three applications. The first applications, these three applications I'll be talking about. The first application I'll take up is common breeding ground or discovery of common breeding ground of eel. Second one, an application in judiciary that I found interesting. The third one, search for USS Scorpion. And the fourth one, the discovery of Higgs boson. I'll be just talking on these three. Let me take the first one. Now, this is, of course, partially it is taken from the same book, Statistics in Truth by late Professor C.R. Rao. Now, in the early 1920s, Danish biologist Jonas Smith of Copenhagen, Denmark, found that the numbers and measurement of vertebrae and fin rays of the same species of fish caught in different locations varied considerably. However, with eels, he observed the same mean and same standard deviation of number of vertebrae in samples of eels drawn from all over Europe, Iceland, as well as Nile, Africa. He inferred that eels of all these different river systems come from a common breeding ground. Later, eel larvae discovered in the Sargasso Sea, far from their freshwater estuarine and coastal habitat in Europe and Africa. I'll just passing comment I'd like to make here. The Sargasso Sea is the only sea in the world which doesn't have any land boundary, and it falls, southeast of North America and northeast of South America. Bermuda Triangle also, it covers the Bermuda Triangle area. Now, publishing his results in 1923, Smith foreshadowed the next century of research to understand how eels reproduce, describing his efforts as disappointment, alternating with encouraging discoveries and periods of rapid progress with other, during which the solution of the problem seemed wrapped in deeper darkness than ever. It was because it's a very large area that Europe, a little bit of Asia, and Africa, and in all these river systems, his proposition that all these eels, what is captured on this entire large area, they have a common breeding ground. So this was difficult to accept, but later on it was discovered and discovered in very recently, concluding evidence were obtained. The eels were captured, tagged with detachable satellite trackers, swabbed for DNA testing, and released back into the Atlantic Ocean from Azores Islands back in 2018-19. This is a recent one. 6 seals reached the Sargasso breeding grounds months later with their satellite trackers still attached. Data from 15 other eels were collected along the way. The longest recorded straight line distance was 2,205 kilometers. So this information was published in the Nature in October 22. So it was recovered. Now, my proposal, you see, only the simple measures like mean and standard deviation, these two suggested, or these two were instrumental for Smith to come to the conclusion that eels of such a large area they belong to, or they have a common breeding ground, which was very difficult to accept even in today's scale. Second example that I'll be taking, which is interesting, another one. That this example is from judiciary. This is from a book, Statistical, influenced by Vijay K. Rohatgi, published in Wiley Series of Mathematics, 1984 edition, page 65. You'll find this example there. There was an elderly lady in Los Angeles. She was hit on her head from behind by a person, and she collapsed. And she was robbed afterwards. On the statements of the lady and some eyewitnesses, the police, these were the evidences that they got that the accused, they came in a yellow car, or the attackers came in a yellow car. There was an interracial couple, and the man has mustache and beard, and the woman has a ponytail and blonde hair. And that was an interracial couple. So in the lower court, they captured one couple. The name is Janet and Malcolm Collins, matched the description, and the lower court convicted the couple because the lower court computed the probability of getting, because Malcolm and Janet, they satisfied all those conditions that is expressed by the witness. And the police computed the probability like this, that the availability of yellow car in that region, Los Angeles, was 0.1, man with mustache 0.25, that is 25% man has a mustache, women with ponytail 0.1, women with blonde hair 0.33, black man with beard 0.1, and interracial couple in a car. So they used product tool for probability, which gave a value 1 in 12 million. That was so small probability, and that's why the court convicted this couple and expecting that they have committed the crime. But the twist came in the upper court. In the upper court, the decision was reversed. It computed the conditional probability that at least one other couple exists matching these characteristics, given that at least one such couple exists as follows. They have taken this P and they have used this conditional probability formula, and ultimately in this limiting case, they could obtain a value of 418. There's 41.8% probabilities there that you can get another couple with similar description as Janet and Malcolm. And this probability was very high, and the accused was released from the upper court. The decision was reversed. So there are several other application of probability theory in judiciary in Europe and America. If you find, you will get some more interesting ones. Now, the third one that I want to take up is the discovery of Higgs boson. Well, this was a big news in 2022, I think, 2021, 22, yeah. So let me start the story from the beginning. Well, we have several theories for the creation of universe. One of them was Big Bang theory, which has the most followers. We have other theories also. Recently, we lost Jayant Narlikar, who's an Indian, and he proposed one of the theories, steady state theory of universe. But I think that is dropped now. Right now, the most accepted theory is Big Bang theory. Now, the Big Bang theory proposes that the universe was created around 13.786 billion years ago, uh, during a time duration of 10 raised to minus 11 seconds. This is so small. And after that, it's expanding. We have many evidence that of the expanding universe, which supports Big Bang theory. In that, the most important problem was that how weight or mass is being obtained. For this, one theory came contradicting the other views that time by proposed by Peter Higgs and others in 1964, that they proposed a new kind of field that fills the entire universe and gives mass to all elementary particles. Now, Higgs boson as a particle is a very heavy particle, and it has many unique properties. One is that it has zero spin, no electrical charge, no strong force interaction, no loss of mass in its disintegration. You see, it's very interesting to know that whenever two particles interact, they disintegrate or they fuse, there is a loss of mass. Now, but Higgs boson will propose that when Higgs boson disintegrates, there is no loss of mass. It's heavy. Its mass is about 130 times larger than the mass of proton, and its lifespan is very short. It is of 10 to the minus 22 seconds. So just imagine the universe was created in 10 to the minus 11 seconds, and the lifespan of Higgs boson is 10 to the minus 22 seconds. Now, Higgs boson can't be discovered by finding, you can just see how small lifespan it has. So it cannot be discovered by finding it somewhere, but has to be created in a particle collision. Once created, it decays into other particles that can be detected in particle detectors. The challenge is that these particles are also produced in many other processes. Plus, the Higgs boson only appears in about 1 in a billion that large hadron collider collisions. But careful statistical analysis of enormous amounts of data uncovered the particles' faint signal in 2012. On July 2012, the ATLAS and CMS experiments at CERN, Switzerland, announced that they had independently observed a new particle in the mass region of around 125 gigaelectron volts, a particle consistent with the Higgs boson. On 8 October 2013, the Nobel Prize in Physics was awarded jointly to theorists Francois Englert and Peter Higgs. But the story doesn't end here. The story continues. I'll just talk about the twist. Experiments based on discoveries requires an experimental design and mechanism for testing of process. In this particular experiment, they have taken there are several characteristics of Higgs boson that was tested, but one common thing in all of them was that there is change in mass. This is what the null hypothesis was taken, that there is change in mass in disintegration, because the property of Higgs boson is that there is no change in mass. Now, after taking this null hypothesis, it can be tested as a population proportional under normality. The announcement of discovery was withheld in 2033, though Nobel Prize was awarded in 2012. As the 2011 result observed the phenomena with plus minus 1.6 sigma away. I'll just recall that most of you or most of us are from statistics, and we know that usually in general experiments, 1.96 sigma away is a very good confidence region, and that gives you 5% level of significance, and we work with that. But this experimental result was very important, and scientists agreed that at least 5 sigma away we need to observe, unless this discovery cannot be declared. So in 2002, result observed this, the experiment continued. In 2012, it was observed with plus minus 3.6 sigma away. The experiment was continued further. Now, there was a glitch in CERN laboratory, and it has to be stopped, and some renovation work was done there, some repair there, so the experiment got delayed. And again in 2018, it was observed that with an with an plus minus 5.1 sigma away, this procedure, this confidence interval. But later it was revised in the calculation to plus minus 4.9 sigma away. The experiment continued further. In 2019, it was observed that plus minus 5.9 sigma away, and the discovery was finally announced in 2019. This gives us a confidence coefficient of 99.9999486%. So it was a very high confidence level, and this was this scientist accepted it that this high confidence level is required for such an important discovery. Well, any new discovery has to go through any experimental result for discoveries has to pass. This is the only way testing hypothesis. You have to plan the experiment, and you have to formulate some kind of hypothesis. You have to obtain data and have some calculations, and then only this discoveries can be reported. I'll take another third one more example from statistics. This reference I've taken from another book, Spatio-Temporal Data, of the book by N. Cressy and K. Wickel, Wiley, 2011. This is on page 24. Now, it says that in May 1968, a nuclear submarine of the US submarines, USS Scorpion, the name was, US submarine Scorpion rather, was lost in Atlantic Ocean somewhere southwest of Azores for unknown regions and unknown location. A search started in June 1968 using Bayesian statistical method under hierarchical modeling approach. First, 20 by 20, that was a huge, in hundreds of miles it was running, that the whole area. First, the area was, first the 20 by 20 spatial grid was demarcated and prior probabilities were calculated and assigned based upon expert opinion. Assignment was non-uniform and attached about 23% probability to 2 of the 400 grids. This was to be updated after every round of search of a grid. Now, detection probabilities were calculated collectively by scientists and engineers, and they were in the hierarchical modeling framework. It was done. It has a conditional probability, Zi, that we are able to search the submarine, we are able to find the submarine, submerged submarine in a particular grid. And given that, Yi is that this is the true state that submarine is in a particular grid. Now, Zi by a given Yi has been assumed as Bernoulli distributed with Yi Pi. This distribution, they are assumed to be independently distributed, and Yi has been taken as a Bernoulli with Pi I. That's the true state. Now, in October 1968, it was found in October 1968, and was located within 260 yards of the edge of the grid box with the highest initial prior probability. So, this is a Bayesian approach of hierarchical modeling. They help in searching the submerged USS Scorpion. A similar methods were used when in 1966 by US military for successful recovery of hydrogen bomb lost in the Mediterranean Sea after a mid-air collision between US Air Force B-52 bomber and KC-135 refueling tanker over Spain. Now, during this 1966 collision, there were 5 bombs there, 5 hydrogen bombs were there. So 4 fell down on the ground, only 1 was lost in the sea. And it was challenged to discover that, and similar kind of method was used, and they were able to recover it successfully. Now I'll take a little more deep dive. I'll like to be a little more involved in my talk. I'll be coming to this thing. I like to talk on reality versus representation of reality. I like to combine all those. You see, I think why not to start from the beginning. We, the Homo sapiens, we evolved around 3,25,000 years ago somewhere in the Nile Valley, Africa. Around 1,50,000 years we stayed there. and we started dispersing, and we started dispersing the last during the last 1,75,000 years. And during this short span of time, 1,75,000 years, we have covered every region of Earth, and we are using every square inch of available land mass as well as the water. We have we have exploited the Earth so much so that almost all the life forms have become endangered. Now, why so? What was so special about us, the Homo sapiens? We have the special in us was our wisdom or intellect, that intellectual capability, storing it, processing things, storing and then updating our information and further processing. So somehow we got this ability, and and uh, we what we started developing. But I'll just like to put you in so what is reality? So just see the universe. You'll find that is one entity. It is not in segments. We can find there are interrelated systems working together. In the universe, nothing happens in a sequence. It happens all together. Now, once we start thinking of the universe, the way we are thinking, and we are trying to identify and uh, recognize this and process things around us, what we want. Okay, we take a chair, for example. Suppose if chair, you have to describe something. Chair is something. Now, if for describing chair, what we'll do, we'll take up only those characteristics by which we will be able to differentiate it from other objects. So we'll talk about its height, its shape, structure, and if our objective will be only to differentiate it from a table, then I'll not enter into what type of material is being used to construct it. So I'm leaving those only. I'm considering only which is important in describing something. So this is the way the way we gather information or describe things. But how far we describe will never be fully able to describe a chair. By saying this, what I mean that the reality where everything happens together is not in sequence. But when we go for representing it, then we lose some parts of reality. We only concentrate on its abstractation. We only can concentrate in its characteristics which we think are important. The intellect, the functions of intellect that we have, the functions of intellect are discriminate, divide, measure, compare, and categorize. This is what we understand by our common sense also, and this is what we gain, what we call in knowledge, that we gain around the events and phenomena that's happening around us. The knowledge advances, and this is also rational knowledge that we call. In basically, it's coming from Western philosophical things, basically based on Greek. But in Greek, just two time periods I'll be writing to discuss. That 6th century Greece, when the idea was that nothing is disconnected. There is one element which pervades all items in this universe, and they call it physics. And I think physics is derived from there, so they didn't have any different name for matter. But slowly, it came to dualism and the soul and body and matter. These got separated during the time of Archimedes, who synthesized the existing knowledge of his time. And he has proposed this dualism, and he has separated soul and matter, which has not existed in 6th century Greece. Under this idea, it advanced, and we came to Rene Descartes and Newton, and this physics. And certainly, we have taken that there are two reasoning paradigms in which scientific knowledge advances. There is deductive and inductive. The deductive reasoning, the framework is like that we have a set of axioms which are self-proved quantities. And suppose given a set of axioms, if we take a subset, we can prove a proposition. Or the truth of the proposition depends upon the truth of the axioms. So in that framework, we were advancing. Recently, also, if you are following media reports, one Ishan Chattopadhyay and David Zuckerman, they were awarded Gödel Prize very recently. Now, Kurt Gödel was a German mathematician logician who proposed in 1931 the Gödel principle of incompleteness. Now, it proposes that any interesting mathematical system based upon a set of axioms is doomed to incompleteness. In other words, you can say that you cannot disprove the possibility that a system based upon a set of axioms, that a system will lead to contradictions. So this was realized, and this gives a limitation of the axiomatic approach or a limitation of deductive reasoning. By 1920s, though people were using inductive reasoning, by 1920, another type of reasoning came into study. That was inductive reasoning. And both were combined together in search for truth. Even one sequence, the search of truth, the scheme for search of truth, if you see, it starts from hypothesis, then a formulation of some consequences, then to the formulation of obtaining data, then from data to inference. Now, from hypothesis to consequences is coming under deductive reasoning. And from data to inference, it comes under inferential reasoning. From consequence to data has been designed in the design of experiment, some kind of design of experiment. And from inference to the hypothesis again, you move under any field of study, it's coming from researcher. So the new knowledge is generated when you are moving from inference to hypothesis again. Scientific knowledge, the advancement of knowledge, which gives you new discoveries, has to follow this path which is acceptable. We started developing under this paradigm, and it was for rational reasoning. I'll just, for the time being, I'll touch upon a little bit of Eastern philosophies. By Eastern philosophy, I mean Indian, Chinese, and Japanese, but today I'll be talking only on an Indian philosophy. So in Indian philosophy, we have also different types of reasoning and arguments. Say it has 6 established schools of philosophy. I'll start from one with respect to the arguments that is being raised or the types of reasoning that is being used. So I'll take the first name of Charvak. I think you must have heard that Javed Jivet, Sukham Jivet, Ranam Kirtwa Kitam Pravet. Now, how far you live, you just live. And happiness, and if required, you on the date also you buy butter and eat. So nothing there. There's no consequences of that. Actually, Charvak uses only one type of reasoning, that is deduction. That's observance. So what he could observe, he says that reality is only that you can observe, nothing beyond that. Next comes Buddha. Buddha philosophy considers 2 types of reasoning, deduction and inference. Third one comes Sankhya. Now, Sankhya philosophy, school of philosophy, considers 3 different types of reasoning, deduction. Say, I'll just recite one. So, Dristim Anumanam Apta Vachanam Sarva Pramana Siddhatvat Trividam Pramana Nistam Prameya Siddhi Pramanadhi. Means Dristam means observance, Anuman means inference, and Apta Vachan means expert opinion. These are the 3 ways to establish the truth of any premise. Find the connect. We have just taken one example while discussing USS Scorpion, and which was searched under Bayesian paradigm. You see, the Bayesian decision-making process uses all the three types of reasoning together: deductive, inductive, and expert opinion. Because there the prior probabilities are coming under expert opinion. Now, in the Indian system, the Sankhya doesn't ends there at Sankhya. You add up another one. There is another school of philosophy which is called Nyaya. The higher school of philosophy added a fourth type of reasoning, which is called upaman, means comparison. So in a modern setup, we are not able to link it up. I think somebody will come up and he will link it up, this comparison also in the decision making process. It doesn't end here. There are several other types also. It goes up to 8, I think, like tarka. Tarka means argument, like vada is discussion, and different types of this. So that's all. I'll shift to some other, the third one, last leg of my lecture, where I'll be talking the transition of statistics from classical statistics to modern statistics to computational statistics. Well, as I told you that during our days when I was studying statistics in graduation and master's degree, I was completely lost. The types of books that we were following, and I've also observed the books that usually in applied areas people follow. I'll just take, for example, I think things will be clear to you. Or before that, I'll just tell you that statistics, the classical statistics, if roughly about to take, this is a rough, just I propose it, rough division from ancient time up to, say, late 19th century. And the modern statistics I like to put from 20th century and to 1970s, and the computational statistics phase I take beyond 1970s to till date. In the old one, statistics, initially we have taken statistics as counting or reporting the counted numbers of people, of cattle, of produce, of soldiers. So those were available since very long time. There were developments taking place, but initially it was thought in terms of as a branch of mathematics that was developing. In mathematics, we are more attached to numbers. There's number theory also, numbers. So that hangover remains in the initial statistics, in the statistics book also, and even in some days, today's book. So the difference between data and numbers were not very visible those days. In the classical setup, say I take an example. You see our books right now, today also, you can, if you want, in search in applied areas, you will find a book, and a very innocent looking example remains there. One example in the averages chapter, where they give you data set and ask you to compute arithmetic mean, geometric mean, harmonic mean, and compare them. Don't you think this is nonsense? If you have numbers, set of numbers, you can compute arithmetic mean, geometric mean, harmonic mean. But if you have a data set, only one of these three will be defined, not the other two. If the data is additive, only arithmetic mean is defined, not geometric mean and harmonic mean. If the data is multiplicative, only geometric mean is defined, not the arithmetic mean or the harmonic mean. If the data is of a weight and different values are given with respect to the numerator, harmonic mean is defined, not the arithmetic mean. The data has to be additive here also. And if it is with respect to the denominator, then only arithmetic mean is defined. So this example even lies today in our books innocently. And to me, these type of examples, they contaminate your concept of statistics. There are some other examples. During this course, I'll be discussing one or two. And there are, again, further, some books are there. See, even starts from the +2 level. When they give you, they don't give you data set. They just give you a set of numbers, and then ask you to compute statistical measures. There are confusion because the average, this word, the way we are taking, for us it is plural, and even the dictionary meaning is singular. So we need to somehow mitigate these kind of confusions, which still remains. Otherwise, the understanding will not be clear. Coming to the statistical modeling or modern statistics framework, I have just as my proposition. I'm not found it somewhere, but I'm telling you that the difference that I understand from classical statistics to modern statistics is the concentration on units and concentration on variable values. In classical statistics, we concentrated in units. Suppose I have to get some data like on height of humans from group. Then first I'll come to mind that I'll concentrate on the units, sampling units, the humans, and then I'll be measuring the data. So I'll be having some minimum value, some maximum value. But in statistical modeling or modern statistics, we do not concentrate on units. We concentrate on varied values. Even any population, whether finite or infinite, just forget it. In statistical modeling framework, our say formulation is different. We take nature to produce as a machine which produces different heights or different age groups. Now, suppose I take an example that this height of humans. Suppose nature has produced and have a population, whether finite or infinite, it doesn't matter. But if I have to model that, I'll be concentrating, okay, what are the possible values of height that this nature can throw? This cross-distance study, you just imagine. You try to measure. Now the thing is, if you are concentrating on unit in the classical framework, you'll be having some minimum height and some maximum height. But if you are concentrating for varied values, the minimum height will go to 0 and the maximum height will go to infinity. Because you are not able to put any upper limit or lower limit. But the moment you put an upper limit, the question will come that, okay, if you accept that a person can be of 8 feet 3 inches, what prevents you to accept that a person can be of 8 feet 3.001 inches? You don't have any answer. So in the statistical modeling framework, we are concentrating varied values, and then our domain of that or support of the variable can be extended up to infinity. Take for example, the lifespan of humans. Lifespan of humans, if you try to do so, if I ask you the minimum, of course, if life was only, we are considering 0. But if I have to put some upper limit to the lifespan, can I get from some of you that can guess what should be the maximum height of maximum lifespan of humans? Any answer from your side?
70 years, sir. 60 to 70.
70 is quite less. You see, recently also we have one Padma Shri. If I remember the name, it is a Baba Shivanand from Varanasi, who died recently in April at the age of 128 years. So 70 is very low because you experience around you. Even Sir's age was 85. So 70 is not acceptable. Can you put any other who can give it a try? Well, I'll tell you what is the problem. Yeah. Okay, I'll tell you what is the problem. Even if you think of putting an upper limit of 150 years that we have not experienced one, with the same problem arise. That if you accept 150 years, why not 150 years and 1 second? And you'll not be able to put an upper limit. And so you have to keep it open. You see, the infinity always doesn't mean a very, very, very large number. It also means that you are not able to put any bracket to that, a limit to the upper limit. So even the lifespan of humans is 0 to infinity. You think this way. You are thinking in statistical modeling framework. You're thinking in modern statistics framework right now. So the lifespan of houseflies is also 0 to infinity. The lifespan of stars is also 0 to infinity. The lifespan of elephants is also 0 to infinity. Now, if you have to make a comparison between them, you cannot make comparison on the whole thing. But one advantage we got, that if we are taking this as varied values, we can represent them using some mathematical function, like the function which goes from 0 to infinity, like say gamma, like say exponential, all those distributions that we're using. So the mathematical modeling approach or the modern statistics allowed us to study the population or to structure the population as a mathematical function. And we started developing this framework. We have both. In our books, you'll find examples from both, from the classical approach, from the modern approach. Like one example I'll be giving you. The most used or misused tool of research methodology is regression. You just take the formula, the smallest formulation of regression. Y is equal to x beta plus epsilon I'm taking. In the classical framework, we take it as we put the assumptions on error that expectation is 0 and variance is fixed sigma square for each values of error epsilon r. So in totality, it gives you a sigma square that can be taken as a global variance. But in statistical modeling framework, this is not the formulation. In the statistical modeling formulation, we assume that y given as the response given the regressor. It follows some distribution. Now we have to assume a distribution, which we are not required to assume in the framework of classical statistics. So now you have to assume normal or some other distribution. Say initially, let me take normal only with a mean x beta and variance sigma square. Now remember, the sigma square here is not the same sigma square that we got in the classical framework, because in this modern statistical framework, regression, this is the conditional model, and here the variance is conditional. And in classical one, the variance is global. Here, this variance is applicable, will be the same only if we are working in bivariate data structure. But in the classical, no requirement of bivariate data structure. It can work in other type of structures also. There is a difference. We hardly make a difference. Rather, in books, we propose that both are same. The problem is, I like to put the classical one as simultaneous approach, because simultaneously putting assumption on every observation. And the second one, I like to put the classical is a conditional approach, y given b. Now, both of these approaches has different. It looks, initially, it gives you the same results, even if you are working in time series autoregressive models where the data is dependent, because the Jacobian transformation is one. So both of them will lead you to the same. Both of these formulation will lead you to the same values, same results. But the interpretation are different. But the moment you enter into higher dependent structure, let's say spatial or spatio-temporal, then these two models give rise to two different results. Interpretations are, of course, different in all the cases. Now, then they don't keep this, then the distinction comes in. Now, my proposition is, if these models show up their difference in spatial and spatio-temporal conditions or with the data structure, why not to tease them that these two models are different even in the very basic setup? Well, one more argument has been given that it's not possible to actually we are putting some distributional assumption in the classical framework even for normality of the error, because we have to construct a confidence interval. Well, in this computational statistics way, do we require this assumption? We don't require. We can, whether the data is dependent, the data is independent, we can construct a confidence interval using bootstrap. Say for dependent data, but you just put the dependent structure there and you sample when, like in time series autoregressive model of first order, given the immediate next or immediate, the preceding or succeeding, the data are assumed to be independent. You capture on this, and then you can let's say in this independent framework, you can generate, you can do bootstrap, you can construct the confidence interval. So there's no harm. Now, in regression, this conditional framework has its own advantages and disadvantages. Now, in sciences, like in statistics also, or in physics, in sciences, we prefer conditional model. But in economics or some other applied areas, social sciences, they prefer the classical model. We carry forward with both of them, but we hardly concentrate on what differences is there, what advantages are there. This, though it is more scientific because it has a mathematical treatment of modern statistics. But in modern statistics, you see, we concentrated or we focus more on the mathematical development of the things. And here our assumptions are much more, which has made our application very, very restricted. Then what we do it for some small area, and then we expand it to larger, just we could close our eyes that, okay, if it is valid for this small set, it may be valid for others. You see, most of our results are concentrated in exponential family of distributions. Few results are there in location scale family, and we are difficult to expand it. But we are applying it. The maximum likelihood framework we apply. Why do we ignore? Because there, mathematically, this ignorance we can ignore it and we can solve it. There are very easy ways now. That this easy ways has started after the computational statistics after 1970s, when we have access to desktop computers and we can write codes, we can write algorithm to solve many difficult problems which otherwise was not previously not possible. Even see the application of Bayesian was made very accessible after computers were accessible to us, and how simple it is to generate data even using a Markov chain, Monte Carlo, and taking expectations of that what we are using. We are using many complicated data structures these days, which was earlier not possible. But we have a resistance from this, from the modern statisticians. Still, they are more concerned with theoretical developments. They don't. They simply they are a little bit shaky in accepting this algorithmic base because the question is always there. If it fails in some conditions, what happens? Well, I have taken in all many limited conditions where it was not. It is reported as not possible. Take even examples of I have done regression of Cauchy regression. Now, the thing is, Cauchy expectation doesn't exist, so you cannot think of a regression. But all such distributions which lead to infinity, if you truncate, expectation exists. So just allow the code to curtail, to truncate the distribution, both the sides at a very, very large difference. When the student probability is very less, and I was able to perform even Cauchy regression, any regression examples or data set that comes to me very difficult, there's no problem. I have used, I have done it using the method of genetic algorithm developed method. It's differential evolution. I've used this method for more than 500 data sets, and in different scenario, I never failed. But yes, this question is there that if in one case you fail, then what happens? I was able to construct, you hardly find in research papers that simultaneous confidence interval using Fisher, what was that? Using the Mahalanobis distance. Using Mahalanobis distance, I did it using, using machines, which otherwise is very, very difficult to find out. Now, I did it, started doing papers around 1914, 15, but the program that I was taking that was available in one of the Munich repository. It was written in Fortran. But fortunately, I learned Fortran in my college days, and I started using it. And I used to send my papers because I thought that, okay, I was able to resolve most of those limitations. But I got a lot many rejections. I succeeded in publishing papers based upon this differential evolution only once this differential evolution package was available or made available on our platform. When I started using it, I'm getting published. I don't know why from this the program which was in public domain was not acceptable. There are so many questions. So some questions are very difficult to understand. You see, another frustrating thing in our subject areas when you are trying to develop is the conceptual contamination that I've told you. Recently, I can talk this year. I've seen two papers which is in Scopus Journal. I don't want to quote the name, but both are conceptually wrong. One of the papers proposes, say, two parameters simultaneously it occurs, and so it is not identifiable. But the whole proposition, and they are also showing that they have fitted the data and estimated the parameters, and this is published in Scopus Journal. Another one I'm quoting where they have a threshold parameter in this distribution. And threshold, when you have a threshold parameter, you're not allowed to, you're not supposed to. It is not valid that you can get solution using a differential likelihood function. It doesn't work, it's not valid. But they have done it, they have reported it that they did it. And they quoted some computer software that they used it and solved the problem. This is absurd. Now you'll find this absolutely going on. You see, just during the COVID time, you'll find a lot many papers which has fitted distributions, assuming that observations are independent on daily COVID data. This is absurd. But this has been published. You'll find it. It is there. So in the research papers also, the condition is very frustrating. It's not starting only from teaching on our books, what is available. I think I should take a break. I can go on like this, but it's we pass the time. And thank you, sir. It's over to you.